So in this video, we are going to be solving linear inequalities, and we're going to ask ourselves the question, is solving a linear inequality the same as solving a linear equation? And what we're going to do is we're going to check that out and see. So what I'm going to start off with is a basic inequality. I'm going to start off with something that's true, and that is that 4 is less than 8. And we all agree that that's true. Now, let's say I decided to add 5 to both sides, as I would with an equation. So if I have 4 plus 5 on the one side, and I have 8 plus 5 on the other, is the inequality sign still true? So 4 plus 5 is 8, and 8 plus 5 is 12, or 13, and 9, yes, is less than 13, and so this is still true. Let's do the same thing with 4 is less than 8. And let's do the same thing if I multiply, multiplied by -2. So if I have 4 times -2 on this side, is it still going to be true that it's less than 8 times -2? And let's see what this answer is. So this is going to be -8. And this is going to be -16. And is -8 less than 16? No, this is false. And so what that means is that when you're dealing with inequalities, that if you multiply or divide an inequality by a negative number, in order to make the answer true, you must reverse the sign. So let's just erase what we've got here, and we'd have to reverse the sign to greater than. Okay, and so we're going to do a couple of examples of this. Okay, let's say, for example, I was asked to solve the inequality 35 minus 2x is greater than or equal to 20. So let's start solving it like we would just solve a regular equation. What I'm trying to do is get x by itself and find out what values of x make this true. So the easiest thing to get rid of is the 35. When we're adding and subtracting, it works just like an equation. So I'm going to subtract 35 on both sides. I'm going to get -2x is greater than or equal to 20 minus 35, which is -15. The next step is I'm going to divide both sides by -2. But because I'm dividing by a negative, I need to reverse the inequality sign. So be careful on the next line. You can write -2x divided by -2, and you can write -15 divided by -2. But it's no longer the greater than or equal to sign. We have to change that sign to less than or equal to make it true. And now we can keep solving. We know that the left-hand side is equal to x, and it's going to be less than or equal to 15 halves, otherwise known as 7.5. And if, again, I was going to graph this on a number line, it would look something like this. I've got 2, 4, 6, 8, and -2, -4, -6, etc. And let me just change colors here. I know that all the x values that make this true have to be less than or equal to 7.5. So that's about here. It can equal 7.5, so I can use a closed circle on here. And it's all the values that run along here less than that. And that's the number line that represents x is less than or equal to 7.5. Now, one other thing that I want to show you is I want to show you how to solve an inequality graphically. Okay, so let's say you're asked to solve the inequality 3x minus 1 is less than 8. And we're going to do it this time, we're going to do it graphically so we can see what that looks like. And the reason we're doing it graphically is this is going to lead us into solving polynomial inequalities. Right now we're just doing linear, but we want to get the idea of what this is going to look like. So I'm going to do it graphically on the graphing calculator, but this could also be done by hand. And what I'm going to do is I'm going to go over to my y equals on my graphing calculator. I'm going to clear what's in there already. And in my first equation, I'm going to put 3x minus 1. And in my second equation, I am going to put the 8. So what I'm doing is I'm going to compare the lines 3x minus 1 to the line y equals 8. And let's take a look at what that looks like. And there we go. And now we have to use our thinking and say, okay, I'm trying to find out when the line 3x minus 1 is less than the line y equals 8. And I want you to read your graph from left to right. So when is 3x minus 1 less than 8? Well, it's less than 8 all the way up to this point of intersection. In other words, it's less than 8 when x happens to be less than 3. If that works the same way algebraically. So we have the inequality 3x minus 1 is less than 8. And we did it graphically, and on the graph we figured out that it was less than 8 when all the values of x happened to be less than 3. Let's see if we're right. So we're going to solve this algebraically. I'm going to add 1 to both sides. Because I'm just adding, I'm not changing the sign. So 3x is then going to equal 9. And then I'm going to divide both sides by 3. And because I'm dividing by a positive value, again, the sign doesn't change. So I'm going to divide both sides by 3. And I now have x is less than 3. And they match. Okay? And one other way that we can check to see if this is true is we could set up a left side, right side equation, or left side, right side chart. And on the left-hand side, I've got 3x minus 1. And on the right-hand side, I've got 8. And what I'm going to do is I'm just going to choose any value for x that happens to fit into this inequality. So I could pick 2, 1, 0, negative 1, negative 2, anything that happens to be less than 3. So what I'm going to do is I'm going to sub in the value x equals 0, because zeros are easy to play with. So if I sub in x equals 0, the left-hand side is 3 times 0 minus 1, which turns out to be 0 minus 1, which is negative 1. And is it true that negative 1 is less than 8? And it is true. So therefore, we know that our inequality solution that we found, that we figured out, is true.